all of the surfaces and faces are flat, like vertical or horizontal. But this one does have one kind of tricky part to it where there's something in the middle that we can't actually see. We have to make a guess as to what's there. I've started off by already drawing my bounding box to make sure that my drawings are actually going to fit on the page, relatively centered, and take up most of the space. I'm going to start this from the top view. I'm just going to work my way from top to bottom, starting off by drawing the flat surfaces that are actually at the very top of the part, which in this case is 2 different rectangles. And the nice thing about drawing these electronically is that I was able to actually scale my graph paper to actually make it so that the isometric squares are the same size as my orthographic view squares as well, which makes counting and measuring a little bit easier, so I don't have to multiply or divide all the lengths to make it fit. But if the squares on your graph paper are much larger, much smaller, you might have to take lengths from your isometric view and multiply them or divide them by the same number to scale them to be the right size. So again, top to bottom, so one step down, and I'm going to see a rectangle over on the right-hand side of the part that I can draw next. Down a little bit further, and there's a horizontal rectangle that's sort of in between the first 2 shapes that I drew. So now this next part, the wall on the right-hand side that's 3 squares tall is actually partially blocking my view of this flat surface. So I'm assuming that this flat surface that I've sort of shaded in blue isn't actually stopped at that diagonal line that I drew. And I'm going to assume that it actually continues all the way around. That's a full L shape all the way to the back of the part. But there's no way to actually know that for sure from just this isometric drawing. It's ambiguous. It's pretty rare to draw hidden lines on an isometric view. And so usually the reader will assume that whatever features are hidden sort of continue what was visibly visible. And so that's why I'm going to assume that this face actually continues into the hidden area and that it's not, for example, a hole that goes vertically all the way down to the bottom. Because if that were the case, we would probably need some extra information to tell us that that hole was there. As a general rule that's not always correct, assume that things that are visible that become obscured in an isometric view sort of continue in a normal sort of way. That's an expected normal assumption you're going to have to make when making orthographic projection engineering drawings from isometric views. So now that I've darkened in those lines, looking again from top to bottom, there's nothing hidden like underneath anything else. So top view's done. If I move to the front view, I'm going to draw from front to back. So the front view has this sort of U shape where the right side's actually just a little bit lower than the left-hand side. So working from front to back, there's this little short surface about 2 squares long visible. And just behind that, right above it, is a 2x2 square would be visible. And now we see that that face is actually larger than just this 2x2 square. So there's going to be a hidden line that comes along with it. But I want to finish all the visible lines first, and then we'll do the hidden lines next. So we'll come right back to this. So now I'm looking at the rest of the front view, right? This top right side that's still sort of wrapped in my orange bounding box to see whether there's visible surfaces here also. So this tall 2x3 section, there's nothing there. It just projects all the way through the shape as a rectangular hole. It's going to be empty. And same thing for that 1x1 square over on the far top right-hand side of the front view. It projects all the way through. It's just a hole, just a complete cutout. So I write the words empty just so I can keep track of what I've looked at so far, but I'm writing this really lightly. Later on, I'm going to come back and erase this. It's obviously not part of the final drawing. To finish up the front view, we need to think about hidden lines. Are there any vertical surfaces in the YZ plane that are behind something? And there is. This blue rectangle is hidden behind a rectangle that's in front of it. So I add in a small hidden line right at its bottom surface. The other 3 sides already have visible lines there, and visible lines have priority over hidden lines. So that's why I'm only drawing a hidden line for the bottom edge. My hidden line is going to connect on the left-hand side, but on the right-hand side, it's actually going to start with a gap. That's sort of an exception to the rule. Normally, hidden lines should start and end with the dash, not the gap. But because there's another visible line just to the further to the right of this, starting the hidden line with the dash would make it sort of a continuation of the visible line that's there. So in this case, I want to start with the gap to make it very clear that the visible line ends at this corner and then the hidden line starts. So right-hand side next, we're going to go from right to left. So we're starting off with this big giant rectangle that takes up almost the entire right-hand side. So for that top row of squares then, I'm projecting back and I'm looking to see if those are visible surfaces or if they're cutouts that go all the way through. And you can see there'll be a visible rectangle on the left-hand side, a small square on the right-hand side, and then a gap in between that's just going to be a hole. So what about hidden surfaces? So of course, those very small top rectangle and squares were just part of much bigger faces. But the bottom parts of those faces are blocked by that big, tall rectangle that's all the way on the right-hand side. So those are going to get drawn in as hidden lines. So I start off by drawing my L shape at the corner first to make sure I have a really well-defined corner. I start the left-hand horizontal line with the dash, but the top vertical line, I'll start with the gap to make it clear that the visible line doesn't continue, that it actually stops. Now, as I draw this shape over on the right-hand side, I'm actually going to do a little bit of erasing and redrawing of my hidden line to make it a little bit cleaner. So that L-shaped corner is going to turn into a sort of T-joint. And then on the upper section as well, where that horizontal line, where the new horizontal dash line meets the old vertical dash line, I also want them to meet at a sort of T section instead of sort of an L in the middle of the vertical line. Do erasing to get rid of any words or text or construction lines or bounding boxes that aren't part of the final drawing. And that's it, final orthographic projections. So orthographic engineering drawings with horizontal and vertical surfaces are probably the easiest kind. So if you're ready to step up in difficulty a little bit and look at drawings that have angled surfaces, right, that are slanted faces, click on this drawing next, and this will have 2 practice drawings that have inclined surfaces.